Now, in this lecture, we will find the radius of the small circle. In the drawing, we have a quarter circle, and we know that angle BCD, this angle equals to 90 degrees. Chord CD equals to 2 units, OD equals to 3 units, and inside the quarter circle we have small circle, and we want to find out the radius of this small circle. Okay, so first of all, in a quarter circle, OD is the radius of this quarter circle, so it will be equal to capital R. R is the radius of the quarter circle, and also angle BOD, this angle must be a right angle. It equals to 90 degrees because of the fact that we have here a quarter circle, so this angle must be a right angle, and OD must be the radius of the quarter circle. Okay, so we will define the center of the quarter circle as point P, so this will be point P, and then we will join together points A and P by a straight line. So actually AP is the radius of the small circle because of the fact that line segment AP exits from the center of the small circle, that is to say from point P, and ends at point A, that is a point on the circle itself. Therefore it is the radius of the small circle. So I will mark it as R, the radius for the radius of the small circle, and then we will join together points P and B by a straight line. And we will define angle ABP as theta, and actually BA is tangent to the small circle at point A, and AP is the radius. And we have the rule that radius and the tangent to the radius are perpendicular to each other. So the rule states that the tangent to the radius, that is also the tangent to the circle, and the radius are perpendicular to each other. So I will read the rule again. The rule states that the tangent to the radius and the radius are perpendicular to each other. So here we have AB, side AB is tangent to the small circle at point A, and it is also tangent to the radius PA at point A. Therefore, the radius and the tangent are perpendicular to each other. That is to say, this angle is a right angle because the tangent and the radius are perpendicular to each other. That is to say, this angle is 90 degrees. Therefore, we can say that tangent theta equals to AP over AB. So in the right triangle APB, in the right triangle APB, tangent theta equals to AP over AB. Okay, but AP is the radius of the small circle, so we can substitute AP by R. So we got that tangent theta equals to R over AB, and here we will multiply this equality by AB, and we will get that R equals to AB times tangent theta. Okay, so in order to find out the radius of the small circle, we must find the value of AB and the value of tangent theta. Okay. In the next step, we will define the touching point between CB and the small circle as X. X is the touching point between CB and the small circle, and then we will join together points P and X by a straight line. So actually PX will be the radius of the small circle because of the fact that PX is exit from the center of the circle, that is to say from point P and ends at point X, that is a point on the small circle itself. Therefore PX is the radius of the small circle. I will mark it as small r. So in the next step, we will prove that triangle ABP is congruent to triangle PBX. So I will draw those two triangles again. So I draw those triangles PBX and triangle APB again. So on these two triangles, we know that AP equals to PX. Both those sides are the radiuses of the small circle, so they are equal to each other. AP equals to PX, and both those two sides are equal to the radius of the small circle, so they are equal to each other. And also PB is a common side. It belongs both to the triangle APB, and PB also belongs to triangle PBX. So PB equals to PB. It is actually a common side. And AB equals to BX. AB equals to BX according to two tangents theorem. Again, AB equals to BX according to two tangents theorem. So actually, two tangents theorem states that the lengths of two tangents from common external point to a circle are equal. I will read two tangents theorem again. Two tangents theorem states that the lengths of two tangents from common external point to a circle are equal. So actually, according to two tangents theorem, if we draw two tangents from a common external point of a circle, that is to say from point B, if we draw two tangents to a circle, then the length of those two tangents will be equal to each other. That is to say, AB equals to BX. Okay? So we actually proved that all the sides of triangle ABP are equal to all the sides of triangle PBX. Therefore, we actually proved that triangle APB is congruent to triangle PBX according to side rule. Okay, triangle APB is congruent to triangle PBX according to side rule. Actually, side rule states that if you prove that one triangle has all of its three sides that are congruent to all the three sides of other triangle, then those two triangles are congruent to each other according to side rule. Okay, so from the fact that those two triangles are congruent to each other, we can derive that angle ABP that equals to theta equals to angle PBX. So angle PBX will be also equal to theta. Angle PBX, this angle will be also equal to theta. Okay, angle APB equals to angle PBX, and both those two angles are equal to theta according to the rule that corresponding angles on congruent triangles are equal to each other. Again, those two angles are equal to each other according to the rule that corresponding angles in congruent triangles are equal to each other. Okay, so in the next step we will extend line segment CB and line segment DO until they intersect with each other or until they touch each other. Okay, and the intersection point or the touching point between CB and OD will be at point B. Point B is the touching point between DO and CB after we extended them. Okay, so actually we know that angle BCD, that is actually we know that angle BCD, we will define the touching point between DO and CB after we extended them as point E. Okay, and actually it is given us in the question that angle ECD, this angle equals to 90 degrees. So actually angle ECD that equals to 90 degrees is the peripheral angle. Again, angle ECD that equals to 90 degrees is a peripheral angle. And we have a rule that states that any peripheral angle that equals to 90 degrees must rest on the diameter of the circle. So I will read the rule again. The rule states that any peripheral angle that equals to 90 degrees must rest on the diameter of the circle. So actually peripheral angle ECD equals to 90 degrees. So according to the rule that I read, it must rest on the diameter of the circle. So ED, the peripheral angle TCE rests on ED. Therefore ED must be the diameter of the quarter circle. According to the rule that I read, ED must be the diameter of the quarter circle. Again, according to the rule that I state that any peripheral angle that equals to 90 degrees must rest on the diameter of the circle, DE must be the diameter of the quarter circle. Okay, so if DE is the diameter of the quarter circle, it equals to 2R. Okay, DE equals to 2R because any diameter is equal to 2 times the radius of the circle, so DE must be equal to 2R, and we know that DO equals to R. So, and OB equals to DE minus DO. So OB equals to 2R minus R, that is to say OE equals to R, and R equals to 3 units. Okay, so OE also equals to 3 units, that is the radius of the quarter circle. In the next step, we will complete the quarter circle to a semicircle. So actually DE is also the diameter of the semicircle and equals to 2R, that is actually 3 plus 3 is 6 units. Okay, the diameter of this semicircle and the quarter circle equals to 6 units. Okay, and again DE is the diameter of this semicircle. Therefore DE is a straight line. Okay, DE is a straight line. So we know that DE is the diameter of the semicircle is especially a straight line. It is also a straight line. and we have a rule that states that the sum of the angles on a straight line is equal to 180 degrees. I will read the rule again. The rule states that the sum of the angles on a straight line is equal to 180 degrees. So, because of the fact that DE is a straight line, the sum of the angles at point O on the straight line DE must be equal to 180 degrees, according to the rule that I stated. Therefore, at point O, we have angle BOB that equals to 90 degrees plus angle BOE must be equal to 180 degrees according to the rule that I stated. 90 degrees plus angle BOE must be equal to 180 degrees. Okay, so from this equality we will subtract 90 degrees and we will get that angle BOE equals to 180 degrees minus 90 degrees is 90 degrees. So angle BOE is a right angle. So this angle is a right angle, and from the fact that angle BOE is a right angle, triangle BOE is also a right triangle, but we have here two vertex angles, angle EBO, and angle ABC are two vertex angles. Okay, angle EBO and angle ABC are two vertex angles. Okay, I will draw them again. Actually, angle EBO, this angle, and angle ABC, this angle, those two angles are vertex angles. And we have a rule that states that vertex angles are equal to each other vertex angles are equal to each other. Okay, vertex angles are equal to each other. So actually angle ABC, this angle equals to theta plus theta, that is to say it equals to 2 theta. Angle ABC equals to 2 theta. And according to the rule that vertex angles are equal to each other, it also equals to angle EBO. Okay, it equals to angle EBO, so equals to angle EBO. So from this equality, we can derive that angle EBO also equals to 2 theta. Okay, so this angle EBO equals to 2 theta. So now we will return to triangle EBO. We know that triangle EBO is a right triangle. Triangle EBO is a right triangle. Okay. Triangle EBO is a right triangle because it has one angle that equals to 90 degrees. Triangle EBO is a right triangle. So we know that the sum of the angles in any triangle equals to 180 degrees. So in triangle EBO, we can say that 2 theta plus 90 degrees plus angle BEO equals to 180 degrees. Again, 2 theta plus 90 degrees plus the size of angle OEB must be equal to 180 degrees. So again, in triangle EBO, the sum of the angles is equal to 180 degrees. That is to say 2 theta plus 90 degrees plus the size of angle EBO equals to 180 degrees. We will subtract 90 degrees from this equality and we will get that 2 theta plus angle OEB equals to 180 degrees minus 90 degrees is 90 degrees. Okay, we got that 2 theta plus angle EBO equals to 90 degrees. So we will subtract 2 theta from this equality and we will get that angle OEB equals to 90 degrees minus 2 theta. Okay, angle OEB equals to 90 degrees minus 2 theta. So this angle OEB equals to 90 degrees minus 2 theta. Okay, angle OEB equals to 90 degrees minus 2 theta. In the next step, we will focus on the right triangle DCE. So in triangle DCE, the right triangle DCE, we also know that the sum of the angles are equal to 180 degrees. The sum of the angles is equal to 180 degrees. That is to say, angle CDE plus this angle that equals to 90 degrees plus this angle OEB that equals to 90 degrees plus 2 theta to 90 degrees minus 2 theta. In total, the sum of those three angles must be equal to 180 degrees. Again, the sum of the angles in the right triangle CDE must be equal to 180 degrees. That is to say, angle CDE plus 90 degrees plus 90 degrees minus 2 theta equals to 180 degrees. So here we have 90 degrees plus 90 degrees is 180 degrees on this side of the equality, and we have 180 degrees on the other side of the equality, so we can cancel 180 degrees because it is in both sides of the equality. So what left after we cancelled 180 degrees, what is left is angle CDE minus 2 theta. Here we have 0, yes, we cancelled 180 degrees, so what is left is 0. So we got this equality that angle CDE minus 2 theta equals to 0. Here we will add 2 theta to this equality, and we will get that angle CDE equals to 2 theta. Angle CDE equals to 2 theta. So this angle CDE equals to 2 theta. Okay. So we will continue to focus on the right triangle DCE. On the right triangle DCE, we know that the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, CD square plus CE square equals to DE square. Again, in the right triangle CDE, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the square of the perpendiculars. CD square plus CE square equals to DE square. Okay. We know that CD equals to 2 units. It is given us in the question. So CD square is 2 square, 2 square is 4. Plus CE square equals to DE square. DE is the diameter of the semicircle, that is to say it equals to 2 out to 3 plus 3 to 6. So DE square is 6 square, and 6 square is 36. So in total we got that 4 plus CE square equals to 36. From this equality we will subtract 4, and we will get that CE square equals to 36 minus 4 is 32. CE square equals to 32 is 16 times 2. Here we will take a root out of this equality, and we will get that CE equals to the root of 16 times 2. And the root of 16 is 4, so in total we got that CE equals to 4 times root 2. Okay, CE equals to 4 times root 2. Okay, CE equals to 4 times root 2. So again, in the right triangle CDE, we know that tangent 2 theta equals to CE over CD. Okay, in the right triangle CDE, tangent 2 theta equals to CE over CD. But we have already found out that CE equals to 4 times root 2, so we substitute CE by 4 times root 2, and we have, it is given us in the question that CD equals to 2 units, so we divide it by 2. So in total we got that tangent 2 theta equals to 4 times root 2 over 2. So 4 over 2 is 2. So tangent theta equals to 2 times root 2. Tangent 2 theta equals to 2 times root 2. Tangent 2 theta equals to 2 times root 2. Again, we have the formula, the radius of the small circle equals to AB times tangent theta. So we want to find out the value of tangent theta, not the value of tangent 2 theta. So I present to you a new trigonometric identity for tangent 2 theta, and from that trigonometric identity we will find out the value of tangent theta. The trigonometric identity states that tangent 2 theta equals to 2 tangent theta over 1 minus tangents square theta. Okay, tangent 2 theta equals to 2 tangents theta over 1 minus tangent square theta. But we have already found out that tangent 2 theta equals to 2 times root 2, so we can substitute tangent 2 theta by 2 times root 2. Okay, and we will get that tangent 2 theta is 2 times root 2, and it is equals to 2 times tangent theta over 1 minus tangents square theta. Okay, so we have this equality from the trigonometric identity. So here we will define tangent theta as x, and we will find out the value of x by solving this equality. Okay, we will define that tangent theta equals to x, and then we'll substitute tangent theta by x in this equality. We will get that 2 times root 2 equals to 2 tangent theta is 2x over 1 minus tangent theta square is x square. Okay, so we got that 2 times root 2 equals to 2x over 1 minus x square. Okay, here we will cross multiply this expression, or we will multiply this equality by 1 over, we will multiply this equality by 1 minus x square, and we will get that 2 times root 2 times 1 minus x square equals to 2x. We will open the brackets here. We will get the 2 times root 2 minus 2 times root 2 x square equals to 2x. Here we will divide this equality by 2, and we will get that root 2 minus root 2 times x squared equals to 2x over 2 is x. So we got that root 2 minus root 2 x squared equals to x. Here we will add root 2x squared to this equality, and we will get that root 2x squared plus x equals to root 2. Here we will subtract root 2 from this equality, and we will get that root 2x squared plus x minus root 2 equals to 0. So this is a quadratic equation, and the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. Okay? So the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. And a, b, and c are the coefficients of the quadratic equation, and x is the variable that we want to find out, and we can find out the value of x by using the special formula for x. X is actually equals to minus b plus minus root of b squared minus 4 times a times c over 2a, when a, b, and c are the coefficients of the quadratic equation, and x is the variable that we want to find out. So in our specific quadratic equation, we know that a equals to root 2, b equals to 1, and c equals to minus root 2. Okay, in our specific quadratic equation, the values of the coefficients are a equals to root 2, b equals to 1, and c equals to minus root 2. C equals to minus root 2. So we will substitute a, b, c in this general formula, the general solution for x, by the specific values for a, b, and c, and we will get that x equals to minus b, b equals to 1, so minus b is minus 1, plus minus root of b squared. B squared is 1 square is 1, minus 4 times a is root 2, times c is minus root 2, over 2a is 2 times root 2. So in total we got that x equals to minus 1 plus minus root of 1 minus 4 times root 2 times minus root 2. Minus and minus is plus, and root 2 times root 2 is 2, and 2 times 4 is 8. And 1 plus 8 is 9. So in total, in the root we have only 9. So x equals to minus 1 plus minus root 9 over 2 times root 2. The root of 9 is 3, so I will write it down. X equals to minus 1 plus minus 3 over 2 times root 2. We have here two solutions for x, or two roots for x. The first solution is actually x equals to minus 1 minus 3 over 2 times root 2. Okay, this is the first solution for x. Minus 1 minus 3 is minus 4. Minus 4 over 2 times root 2. And minus 4 over 2 is minus 2 over root 2. So in total we got that x equals to minus 2 over root 2. That is to say, x is negative. X is less than 0 is negative. And actually, in our drawing, we have right triangle ABP. In the right triangle ABP, we have angle theta. So the biggest angle here is 90 degrees. So if this is 90 degrees, then the sum of those two angles will be equal to 90 degrees. So theta plus angle APB equals theta plus angle APB, theta plus angle APB equals to 90 degrees. So theta equals to 90 degrees minus angle APB that is to say angle theta is less than 90 degrees because it equals to 90 degrees minus angle APB. So angle theta is less than 90 degrees. So tangent theta x equals to tangent theta. Yes? So tangent theta is a positive when theta is less than 90 degrees. If you look on the graph of tangents, when tangent theta is between 0 to 90 degrees is a positive. So tangent theta the x that is tangent theta is a positive. And we found that x that equals to tangent theta equals to minus 2 over root 2 is negative, and we found out that x that equals to tangent theta must be a positive. So there is a contradiction. X cannot be a negative number because it must be a positive number. Okay, so this answer is incorrect answer. X equals to minus 2 over root 2, that is a negative number. It is incorrect because x must be a positive number. Okay, so the other solution is the only solution that can be correct, that x equals to minus 1 plus 3 over 2 times root 2. Minus 1 plus 3 is 2, and 2 over 2 times root 2. 2 over 2 is 1 over root 2. So x equals to 1 over root 2. X equals to 1 over root 2. And we defined x as tangent theta. So we found out that x that equals to tangent theta, it equals actually to 1 over root 2. X equals to 1 over root 2, or tangent theta, that x that equals to tangent theta equals to 1 over 2. So tangent theta equals to 1 over 2. And we have already found out that tangent 2 theta equals to 2 times root 2. And the radius of the small circle equals to AB times tangent theta. And we have already found out that tangent theta equals to 1 over root 2. So the only thing that is left to find, in order to find out the value of r, that is the radius of the small circle, the only thing that is left to find is to find out the value of AB. Okay? So we will focus on the right triangle EBO. So on the right triangle EBO, we know that tangent 2 theta equals to OE over OB. Okay, in the right triangle EBO, we know that tangent 2 theta equals to OE over OB. But we have already found out that OE equals to 3. Okay, so tangent theta equals to 3 over OB. And we know that tangent 2 theta equals to 2 times root 2, so we can substitute tangent 2 theta by 2 times root 2. We will get that 2 times root 2 equals to 3 over OB. So 2 times root 2 equals to 3 over OB. Here we will multiply this equality by OB, and then we'll divide it by 3. We'll get that OB equals to 3 over 2 times root 2. So we found out that OB equals to 3 over 2 times root 2. So here we can write that OB equals to 3 over 2 times root 2. Okay? So in the next step we will join together points P and O by a straight line. So actually triangle APO is a right triangle because of the fact that angle OAP is a right angle. We have already proved that angle OAP is a right angle, so triangle OAP is a right triangle. In the right triangle OAP, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. Okay, in the right triangle APO, in the right triangle in the green color, triangle APO, according to the Pythagoras theorem, AP square plus AO square equals to PO square. Okay, again, in the right triangle, triangle APO, AP square plus AO square equals to PO square. In the next step, we will extend OP. We will extend the hypotenuse OP until it touches the two circles at point M. The touching point between the hypotenuse OP and the two circles will be defined as point M. So actually MP is the radius of the small circle because of the fact that it starts from the center of the small circle, that is to say from point P, and ends at point M, that is a point on the small circle itself. So MP equals to small r. MP equals to small r. MP equals to small r. And what is the size of OM? O is the center of the semicircle, and M is a point on the semicircle itself. So OM is the radius of the semicircle. It equals to capital R. OM equals to capital R. OM equals to capital R. So what is the value of OP? OP equals to OM minus MP. Again, OP equals to OM minus MP. OP equals to OM minus MP. Okay? OP equals to OM minus MP. But OM is the radius of the semicircle, that equals to 3 units. And MP is the radius of the small circle, that equals to small r. So in total, we found out that OP equals to 3 minus small r. Okay, we found out that OP equals to 3 minus small r. Okay, so we have the equality that AP square plus AO square equals to PO square. AP equals to the radius of the small circle. So AP square will be equal to small r square plus AO square equals to PO square. We have already found out PO and OP is the same. We have already found out that PO equals to 3 minus R. So PO square will be equal to 3 minus R square. So in total, we got that R square plus AO square equals to 3 minus R square. Here we will open the brackets in this side of the equality. 3 minus R square is actually equals to 9 plus R square minus 6R, all equals to R square plus AO square. So here we have R square in this side of the equality, and we have R square on the other side of the equality, so R square will get cancelled, and what is left after we cancelled R square? We left only with AO square equals to 9 minus 6R. Okay, here we will take a root out of this equality and we will get that AO equals to the root of 9 minus 6R. We found out that AO equals to the root of 9 minus 6R. And we have already found out that OB equals to 3 over 2 times root 2. OB equals to 3 over 2 times root 2. And what is the size of AB? AB equals to AO minus BO. Again, AO minus BO, AO minus BO equals to AB. Okay, AB equals to AO minus BO. AB equals to AO minus BO. Okay, AB equals to AO minus BO, so AB equals to AO. What is the size of AO? AO equals to root of 9 minus 6R minus BO. BO equals to 3 over 2 times root 2. We actually found out the value of AB. AB actually equals to the root of 9 minus 6R over 3 over 2 times AB equals to the root of 9 minus 6R minus 3 over 2 times root 2. And we have already found out that tangent theta equals to 1 over root 2. And we know that the radius of the small circle equals to AB times tangent theta. So what is left to do is to substitute AB in this equality by this expression and to substitute tangent theta by 1 over root 2. So we will do it now. R equals to AB. AB is the root of 9 minus 6R minus 3 over 2 times root 2 times tangent theta is 1 over root 2. So here we will multiply this equality by root 2 and we will get that root 2 times R equals to the root of 9 minus 6R minus 3 over 2 times root 2. Okay, so here we will add to this equality 3 over 2 times root 2. We will get that root 2 times r plus 3 over 2 times root 2 equals to the root of 9 minus 6r. Okay, so we got that equality, and here we will multiply root 2 by 2 times root 2, and then we will divide it by 2 times root 2 in order to have a common factor with this expression. So we will get that root 2 times r, we will multiply it by 2 times root 2, and then we will divide it by 2 times root 2, so we change nothing, plus 3 equals to 9 minus 6r, root of 9 minus 6r. So here we have 2 times root 2 is 2, and 2 times 2 is 4. So in total we have here 4r plus 3 in the numerator, 4r plus 3 over 2 times root 2 equals to the root of 9 minus 6r. Here we will square this equality. We will square this both sides of this equality, and we will get that 4r plus 3 square, 2 times root 2 square is 8, equals to the square of a root. The square cancels the root, so we left only with 9 minus 6r. The square and the root is two opposite functions, so if you do something and then you cancel it, you actually in this way actually you squared the root, so you actually canceled the root, because the square is the opposite function of the root. So if you square the root, then you actually cancel the root. So we left only with 9 minus 6r. So here we will multiply this equality by 9, and we will get that 4r plus 3 squared equals to 7 times 9 is 72, 8 times minus 6r is 48r. So in total we got that 4r, here is 4r plus 3 square equals to 72 minus 48r. Here we will open the brackets in this side of the equality. 4r plus 3 square is 16r square plus 9 plus 4r times 3 is 12r, 12r times 2 is 24r, equals to 72 minus 48r. Here we will add 48r to this equality, and we will get that 16r square plus 9 plus 24r plus 48r is 72r, equals to 72. So here we will subtract 72 from this equality, and we will get that 16r square plus 72r equals to 9 minus 72 is minus 63, equals to 0. So here we got a quadratic equation, and the coefficients of this quadratic equation is a equals to 16, b equals to 72, and c equals to minus 63. Okay, and the solution for a quadratic equation is x equals to minus b plus minus root of b squared minus 4 times a times c over 2a. When a, b, and c are the coefficients of the quadratic equation, then x is the variable that we want to find out. In our specific quadratic equation, the variable x equals to r. Okay, so the only thing that is left to do is to put the data inside this formula, and we'll find out the value of r. So here x equals to r, so we'll get that we substitute x by r equals to minus b equals to 72, so minus b is minus 72. Minus 72 plus minus root of b squared, 72 squared is 5,184, minus 4 times a times c. 4 times a is 4 times 16 is minus 64, times minus 63 is plus 4,032 over 2a, a equals to 16, so 2a is 32. So in total we got that the radius of the small circle equals to minus 72, r equals to minus 72 plus minus root of 5,184 plus 4,032 is 9,216 over 32. Okay, so actually the radius equals to 72, the radius of the small circle equals to minus 72 plus minus. The root of 9,216 is 96, so I will write it down. The radius of the small circle equals to minus 72 plus minus the root of 9,216 is 96 over 32. So the first solution to this equation is that r equals to minus 72 plus 96 over 32, and 96 minus 72 is 24, and 24 over 32 is 3 over 4, or 0.75 units. Okay, so the first solution is that the radius of the small circle equals to 3 over 4 units, or 0.75 units. That is the first solution to the question, but we have also the second solution. The second solution to the question is that the radius of the small circle equals to minus 72 minus 96 over 32 equals to minus 168 over 32. It is equal to minus 5.25. So r equals to minus 5.25, but the radius must be a positive number. Therefore, this possibility is incorrect. So the only answer that is left is that the radius of the small circle equals to 3/4 units, or it equals to 0.75 units. Okay? So the answer to the question is that the radius of the small circle, the radius of this small circle equals to either 3/4 units or to 0.75 units. Okay, so now I will summarize the lecture. Actually, we wanted to find out the radius of the small circle. We know that angle BCD equals to 90 degrees, and we know that chord CD equals to 2 units and DO equals to 3 units. And actually, in a quarter circle, DO is the radius of the quarter circle, and also angle DOA equals to 90 degrees. Okay, so actually we defined the center of the small circle as point P. Then we drew here two radiuses of the small circle. We defined this as small r, and actually triangle ABP is a right triangle because the radius and the tangent to the radius are perpendicular to each other, so angle PAO is a right angle, therefore triangle APB is a right triangle. So in the right triangle APB, we defined angle ABP as angle theta. So in the right triangle APB, tangent theta equals to AP over AB, and we know that AP equals to R, so tangent theta equals to small r over AB, and again tangent theta equals to small r over AB. We multiply this equality by AB, and we found out that the radius of the small circle equals to AB times tangent theta. So in order to find out the radius of the small circle, we must find the value of AB, and we must also find the value of tangent theta. Then we actually proved that those triangles, triangle ABP and triangle PBX, are congruent to each other. I drew those two triangles again. On those two triangles, we know that PX equals to AP. Both those two sides are equal to the radius of the small circle, therefore they are equal to each other. BP equals to BP. BP is a common angle. It belongs to both triangles. And also AB equals to BX according to two tangents theorem. Two tangents theorem states that the lengths of two tangents from common external point to a circle are equal. So actually we have two tangents to the small circle, tangent AB and tangent BX. Both those two tangents exiting from a common point, that is point B. Therefore those two tangents are equal to each other. That is to say, AB equals to BX. AB equals to BX according to two tangents theorem. Therefore, we actually proved that all the sides of triangle PBX are equal to all the sides of triangle APB. Therefore, those two triangles are congruent to each other. according to side rule. Okay, from the fact that those two triangles can go into each other, we can derive that angle ABP equals to angle PBX, and we defined angle ABP as theta, so angle PBX that equals to angle ABP must be also equal to theta. So those two angles are equal to theta. Okay, so actually we have here angle BCD that equals to 90 degrees, and angle BCD is a peripheral angle, and we have a rule that any peripheral angle that equals to 90 degrees must rest on the diameter of the circle. So according to this rule, angle DCE, a peripheral angle DCE that equals to 90 degrees, rests on the diameter of this quarter circle. That is to say, DE is the diameter of the quarter circle. Okay, and then we completed the quarter circle to a semicircle, and we know that D is the diameter of the semicircle. Therefore, it is a straight line, and we have a rule that the sum of the angles on a straight line is equal to 180 degrees. So at point O on the straight line PE, the sum of the angles is equal to 180 degrees. That is to say, this angle that is 90 degrees plus angle EOB must be equal to 180 degrees, or 90 degrees plus angle BOE must be equal to 180 degrees. We subtracted 90 degrees from this equality, and we found that angle BOE equals to 90 degrees. So this angle is a right angle, and therefore triangle BOE is a right triangle. And actually, by extending CB and DO, we created two vertex angles. Those two angles in the right color are vertex angles, and we have a rule that vertex angles are equal to each other. Therefore, angle ABC equals to angle EBO. Angle ABC equals to angle EBO, and angle ABC equals to theta plus theta is 2 theta. Angle ABC equals to 2 theta, and angle ABC equals to 2 theta, and we all know that those two vertex angles are equal to each other. So angle EBO also equals to 2 theta. Okay, angle EBO also equals to 2 theta, so this angle equals to 2 theta, and then the sum of the angles in triangle EBO equals to 180 degrees, so 2 theta plus 90 degrees plus this angle equals to 180 degrees, and by solving this equality, that 2 theta plus 90 degrees plus the size of this angle equals to 180 degrees, we found out that angle OEB equals to 90 degrees minus 2 theta. This angle equals to 90 degrees minus 2 theta, and then we focus on the right triangle, CDE. We know that the sum of the angles in triangle CDE equals to 180 degrees. Therefore, angle CDE plus this angle plus 90 degrees plus this angle that equals to 90 degrees minus 2 theta must be equal to 180 degrees. So we found out that angle CDE, this angle equals to 2 theta. And then we continue to focus on triangle, the right triangle, triangle DCE. We know that the sum of the square of the hypotenuse equals to the sum of the squares of the perpendiculars in any right triangle. So in the right triangle CDE, CD square plus CE square equals to DE square. CD square plus CE square equals to DE square. CD equals to 2, so this CD square is 2 square, 2 square is 4, plus CE square equals to DE. DE square, DE equals to 6, because it is the diameter of the semicircle that equals to 2r. R is 3, so 2r is 6. So DE square is 6 square is 36. So 4 plus CE square equals to 36. We subtracted 4 from this equality and we got that CE square equals to 32. And so we found out that CE equals to 4 times root 2. Okay, and then in triangle CDE, tangent 2 theta equals to CE over CD. Tangent 2 theta equals to CE over CD. But we have already found out that CE equals to 4 times root 2 and CD equals to 2 units. This is given us in the question. So we found out that tangent 2 theta equals to 2 times root 2. But we want to find out the radius of the small circle that equals to AB times tangent theta. So we have to find out the value of tangent theta and not the value of tangent 2 theta. So in order to find out the value of tangent 2 theta from tangent tangent 2 theta, we use trigonometric identity that states that tangent 2 theta equals to 2 tangent theta over 1 minus tangent square theta. Okay, we know that tangent 2 theta equals to 2 times root 2, so we can substitute tangent 2 theta by 2 times root 2. Okay, and we got this equality that 2 times root 2 equals 2 tangent theta over 1 minus tangent theta square. And then we define the tangent theta as x, so we substitute the tangent theta by x. We got quadratic equation, and we solved the quadratic equation, and we found out that the value of x, that is tangent theta, is actually 1 over root 2. So tangent theta equals to 1 over root 2. And we already found out that tangent 2 theta equals to 2 times root 2. And we know that the radius of the small circle equals to AB times tangent theta, so we found out that tangent theta equals to 1 over root 2, so the only thing that is left to find is the value of AB. Okay, so in triangle EBO, this small right triangle, we know that tangent 2 theta equals to OB, tangent 2 theta equals to OE over OB. Okay, tangent 2 theta equals to OE over OB, but we know that OE is the radius of the semicircle, is equals to 3 units. It is given us in the question, so it is 3 over OB, but we know that tangent 2 theta equals to 2 times root 2, so we can substitute tangent 2 theta by 2 times root 2. Okay, so we substituted tangent 2 theta by 2 times root 2, and we found that OB equals to 3 over 2 times root 2. So this OB or BO equals to 3 over 2 times root 2. And then we connected together points P and O by a straight line. We know that triangle APO is a right triangle because angle OAP is a right angle. So in the right triangle APO, we can implement the Pythagorean theorem that states that AP square plus OA square equals to PO square. We found out that OP equals to MO minus MP. That is to say, OP equals to MO is capital R and MP is small r. So OP equals to capital R minus small r, and capital R equals to 3. So OP equals to 3 minus R. Okay, so, and we know that AP is the radius of the small circle. So AP square is small r square plus OA square equals to PO square, and PO square is 3 minus R, so PO equals to 3 minus R, so PO square is 3 minus R square. Okay, so we got that R square plus AO square equals to 3 minus R square. Then we opened the brackets here, and we found out that OA, it is the only missing variable, OA equals to the root of 9 minus 6R. And we have already found out that OB equals to 3 over 2 times root 2. We have the value of OA, we have the value of OB, and AB equals to OA minus OB. Again, AB equals to OA minus OB. AB equals to OA minus OB, or BO, it is the same. Again, AB equals to AO minus BO. So we have the value of AO, it equals to root of 9 minus 6R, and BO equals to 3 over 2 times root 2. So the only thing that is left to do is to substitute AO by this value and to substitute BO by this value. And we found out that AB equals to this expression, and we already found out that tangent theta equals to 1 over root 2. So, and the radius of the small circle equals to AB times tangent theta. So the only thing that is left to do is to substitute AB by this value and to substitute tangent theta by 1 over root 2. So we did this, and we got a quadratic equation, 16R squared plus 72R minus 63 equals to 0. And we solved this quadratic equation, and we found out that the radius of the small circle equals to 3 over 4 units, or 0.75 units. And the second answer for R, that equals to minus 5.25 units. It is impossible because the radius of the circle must be a positive number. Therefore, we left only with the answer that the radius of the small circle equals to 3 over 5 units, or to 0.75 units. Okay, the radius of this small circle equals to 3 over 4 units, or to 0.75 units. Okay, thank you very much.